Okay, so I want to go to, um, let's go here to the graph, and I'm going to open this. Let me see. I want to open this in a new tab, and I'm trying to figure out how I can do that. Move to home sheet. There we go. Okay. So here I want to bring your attention to this point of the graph. And this is about the 4.5, 5 minute mark here. At this point in the graph, the line is rather flat. Yes, I do know it does increase, but it's still rather flat. And then we have the other part of the graph where the line is much more diagonal. So here the line is more flat and horizontal, and here there's a significant increase. It's a diagonal line. So what is this telling us? Okay, well, it says that from 0 to about 5 minutes, the temperature is quite low. All right, it's definitely below 20, maybe below like 15 degrees. That's where it is. For 5 minutes, it remains this low. Then from the 5 minute mark until the end, which is about 7.5 minutes, we see a significant increase in temperature from about 15 degrees Celsius up to 50 degrees Celsius. So the question becomes, what is going on here? What's happening here and what's happening here? As far as the actual substance. So we were talking about ice. If we were looking in the beaker right now, we looked in the beaker during this part, in the red part, what would we see inside the beaker? You would probably see some ice, but would you also see water? The answer probably is yes. You'd see some liquid water in here too. Okay? So basically, what we're saying is you would see solid, and I'm sorry, I apologize for my typing, my writing, but I'm trying to write this with the mouse. You would see solid and liquid at this point. But what about over here? Once the line is diagonal, if we looked inside the beaker, what would we see? What would we see? Well, based on what we read today in class, the answer is we would see liquid water. Liquid water. So all liquid. All liquid at this point. Oops. Okay. That's what's happening here. So if that's the case, what would we say is, again, what's going on here? If you have two phases present, sounds to me that perhaps that's how, or that's when we have a phase change occurring. So we're going to leave this and go to our reading. And if you look here in the reading, what does it say? What happens? Okay, I'm sorry. Okay, very quickly. What happens to temperature during a change of state? While a substance is melting or freezing, the temperature remains constant until the change of state or phase change is complete. That is the point I want to make sure you guys get for today, and we will